In our second example, we will follow the same 4 steps, and of course we will also draw a VIRP table. So if we first start off by filling out all the information that is known, we know that we have 3 resistors, and we know that the resistance values of those are 3, 6, and 5 ohms respectively. So I can enter that into the resistance column, and we know that the total voltage is being supplied by this battery, and it's 60 volts, so I can fill in all the information that is given to us in this problem. Once again, this is a series circuit. To find the total resistance in a series circuit, we simply add up those resistances. So if I add up my resistances of 6, 3, and 5, I should get 14. Once I know the voltage and the resistance in any one column, as we do here in the total column, or the total row, I apologize. Once we know 2 or more values in any one row, we can find out the other values. So I can simply apply Ohm's law, knowing that V equals IR. I can go ahead and plug in my voltage of 60, my total resistance of 14, and determine that the total voltage coming out of this battery is 4.29 amps. I can then say that this is a series circuit, so I can apply that current everywhere. There's only one pathway, there's nowhere else for that current to go. And once I have that information, I can simply use Ohm's law, V equals IR. And that's how I can figure out the voltage for each of those resistors. And once I have V, I, and R, I can utilize my power equation, either P equals IV, P equals I squared R, or P equals V squared over R. Any one of those will get me the power outputs in watts. Once I've done this, I can quickly double check and do my self-check. I recognize in the voltage column, it costs me 12.87 volts to get through the first resistor, 25.74 volts to get through the second resistor, and 21.45 volts to get through the third. And if I add those 3 up, you will find you're in the ballpark of 60 volts, depending on how much we rounded. And if your voltages through each resistor that you must pass adds up to your total voltage, you know you have about a 99% chance of having done this correctly. So it's always important to use that voltage self-check through any individual pathway. Obviously much easier in a series circuit as there is only one pathway.